In today's lesson we're going to look at doors, the different types of doors, and then what could be asked on a construction studies exam on doors. Now basically a door is a hinged barrier used to close openings in the wall. So that's the definition of actually what a door does. Now there's a few design features about doors. For accessibility for all users, it has to be at least 800 wide. For a person on crutches, 900 wide, and then for a person with a guide dog would be 1100. So if you're designing a house for a person that has a guide dog, the width of the door would have to be 1100. Now handles and doorbells, level threshold and letterboxes should suit all users. So that means we'll say the handles have to be down low, the doorbell has to be positioned down low so that a person in a wheelchair can actually reach the doorbell. Now security, all doors now, most modern doors are fitted with a 5-lever lock system. So that means that at 5 points that the door is actually locked, rather than the old-fashioned method of locking a door with just a simple mortise lock. Now durability, doors can be painted, varnished. Most modern doors are made from a material that does not need a lot of care, such as PVC or aluminium. If you have teak doors or timber doors, they have to be varnished and painted every 2 years. Now thermal properties, really important that a door keeps in the heat and stops the cold from coming in. Aesthetics, colour, detailing and of the door is important as well. Now if we look at the types of doors, these are all external doors that could be found in a person's house. First type here is a matchbox with a fan light overhead, so it's a rectangular fan light, so what it is letting light into the hallway. Then this is a matchbox with a small light and so on. Over to the door over on the right hand side, this is your traditional 4-panel door. And the reason it's called a panel door is because there's 4 panels used in the actual door. Okay, so you've 1, 2, 3, 4. This here would be a partially glazed and panel door. Now what we have in this diagram here is a ledged and battened door found on many garden shed. This one here slightly stronger with braces, and then the hinges, to hinge this door, the hinges have to be placed on this side here. So this is the side here that it has to be hinged on, because the force of the weight of the door is coming down along the brace here and it's going into the hinge here. If you were to hinge it from the opposite side, you'd have force coming down along here, transferring the weight down along here, and the door would be catching on the ground. Now the next section here, we have similar door again, but we have a frame around it this time. So again, a stronger type of door. And again, if we look at the way the bracing is done in this door, the hinges will be put at the right hand side. Now this here is, we'll say, a joint that would be used. So we have a bare-faced tenon joint used here in the bottom of the door. Now we have samples of doors. So these are external doors of a house. So what we have here is a 6-panel door. Top 2 panels here are glass, and then we have 4 panels underneath. Now in this door here we have a 4-panel door, and what we have is a fan light overhead. Now these are what look like fairly modern doors, but in the future, with all the new building requirements, letterboxes will no longer be allowed to be put onto doors. All letterboxes will be installed on the outside, a box on the outside of the wall, and the reason for this is to prevent the heat loss that escapes out through the letterbox and to create an airtight house as well. Now looking at the sections of the door, what we have is we've several parts. We've the top rail at the very top of the door, bottom rail, and this rail in the center of the door is called the lock rail. The reason it's called a lock rail is because the door lock is mortised into this timber section here, so it's called the lock rail. Now the center piece of timber going down through the door is called the mullion. Now this here is the first, or is the second, this here is the first, this small piece of wood here, and this is the third. So they're done in sections. The side piece of the door here, this is called the style of the door. So you have the lock style, and then you have the hinge style over on this edge. Now this here is what the door looks like when it's taken apart. Now, very important thing to notice is at the top of the door, it's jointed together with a haunch mortise and tenon. And the reason why there's a haunch mortise and tenon used is the haunch piece of the joint is there to stop the door from twisting. So the top of the door will not twist. So if we take a closer look at the top here, this tiny piece of timber at the top of the top rail slots into a groove in here, and that stops the top of the piece of timber from ever twisting. So it's important that that never twists or cups, because it's going to be up flush against a door frame. Now there is a video here on your OneNote to look at doors being manufactured. So all you have to do is click on the link here and watch that video. Next we'll have a look at internal doors. So internal doors, doors that are found inside in your house, there is two main types. The first type here is called a flush door. Now a flush door is a door here with wood placed all the way around. It has a block of wood left inside in the door here to receive the lock, but the rest of the door here is filled with cardboard. So it's in hexagonal shape here, but it's filled with cardboard. Then there's plywood faced on either side of the door. The reason for the cardboard is to stop the plywood from moving in and out. So what it is, it acts as a bit of structure for the door, and it stops the plywood from moving in and out as the door is being opened and closed. Now these are extremely light doors, and normally when they're found in a house there is only 2 butt hinges on the actual door. Now when you buy the door, say for example this door here, you will not know whether the block of wood is placed inside here or in this side here. So what it is, it's printed on the very top of the door, on the top edge of the door. Lock is printed there, so that will tell you that that side of the door receives the lock and the other side is for hinging. Now this is the exact same door. The only difference on this door is it's made to look like a panel door. How this is done is it takes MDF, and the MDF is pressed into this shape here. But if we were to peel off all this MDF, we'd find all this cardboard structure inside in the door. Now the next type of doors are your traditional panel door, so your 4-panel door made from pine in this case. Then we have these doors here called French doors because of the way they're glazed. Now there is a video here to show you how doors are manufactured in a factory. The next section here is fire doors. Fire doors are found in all public buildings, and what it is, there's a lot of features when we look at fire doors, and what makes fire doors, we'll say, different to the normal run-of-the-mill doors that we'd find in our own homes. Now first of all, they vary in thickness. The minimum thickness for a fire door is 44 mils, and that's for a half-an-hour fire door. And then it's 54 mils for a 1-hour fire door. All the doors must be self-closing. So the door into the classroom has a self-closing mechanism, and that's because it's a fire door. Now the fire door must resist the passage of fire for a set period of time. The frame or the door must be fitted with an intrusion strip. Now this intrusion strip, once the heat in the room gets a certain temperature, it seals the door shut, and what it does, it stops any smoke or fire from spreading to another part of the building. Now door frames must be hardwood or impregnated with a fire protection solution. So what it is, that's to prevent that from burning down as well. So what it is, it must be hardwood or impregnated with a fire protection solution. So same as if you were preserving a piece of wood using pressure treating, this here is the same method, but this is with a fire protection solution. Now the door frame must be rebaited to form in a solid or glued and screwed stop, minimum 25 mils. Okay, so we'll have a look at all these in particular photographs and diagrams. The construction of a fire door generally consists of the inner frame of two rebaited edges, and we'll look at why they're rebaited. A plaster slab is covered with a fire resisting material such as 6 to 10 mils of Firex. Now this material then is covered with ply. So when you look at fire doors, basically you're seeing a plywood finish or a veneered finish on the outer edge of the door. Then along the edge of the door then you have a hardwood strip. Now the intrusion strip then is either placed in the door, and we'll have a look at a photograph of that, or it's put into the door frame. So next thing about fire doors is glazed panels in fire doors must have a minimum of 6 mil thickness of glass, and it has to be wired glass. So if you look at a fire door there and how to identify it, if there is wired glass in it, it's a good chance it is a fire door. Okay, now the glazing section in a fire door for a 30-minute door has to be no bigger than 1.2 square meters, and in a 1 hour fire door it's 0.5 of a square meter. So a small bit of glass used in an hour fire door. Now glass must be fitted with 13 mil beads and painted with 2 coats of iridescent paint. Now when hanging fire doors you must have no bigger gap than 3 mils. Now looking at fire doors as well, all fire doors are hung with 3 hinges because of the weight of the doors. So if we have a look at this diagram here, then this diagram broke into 2 parts. We have, we'll say, an elevation of the fire door here, and what we have here is a cross section, so to show what the door looks like when it's sliced down through the center. So if we look at the cross section first, at the top here we have the top rail, bottom rail, and then the lock rail here in the center. And what you'll notice is the rebate taken out of this. So the rebate we were talking about earlier is taken out of this here. Then fitting into that rebate is a plasterboard slab. So, and the reason why plasterboard slabs are used is they do not burn, they're non-combustible. So what it is, they offer great fire protection. Outside that is a layer of Firex. So this here is a cement board that will not burn. So again, fire resistant again. And then on the outside of the door is your ply or veneered finish. So what it is, when you look at this door, you're looking at a veneered finish door, but you don't see all the materials that's gone on the inside. Now the elevation of the door then just shows the exact same thing, but what we're looking at here is the square sections. Now these are a few photographs of these doors. So what we have here, this blue symbol is on all fire doors here, so that shows you that it's an FD60. So FD is fire door and 60 is the amount of minutes that the door will last for. So what we have here is, we have, we'll say, what you'd find in any hotel. Then in this diagram here it shows the wired glass and then the 2 pieces of Intrusion strip here used at either side. So if a fire was to break out, these strips would expand with the heat and seal the glass and the timber to make sure no smoke would travel out. Now this is your fire symbol again. This here is your self-closing mechanism. This here is the Intrusion strip in the door, and we have this mortise lock here, so it has to stop at the mortise lock, but then directly underneath the mortise lock it continues. In this section here shows the intrusion strip if it's used on the door frame. Now it can be used in either the door frame or the actual door itself. So either, but never in both. The only time that this is done on the door frame all the way around, and then if it's done on the door frame, there is one piece of this strip placed on the door, and that's on the underneath side of the door to seal the door to the floor. Now for this to expand, the temperature in the room needs to reach 500 degrees Celsius. So this strip here needs to heat up to 500 degrees Celsius, and when that happens it expands and seals the door shut to the frame, so to prevent any smoke from escaping out of the room. Now these are videos down here, really good videos to show you what happens when we're testing fire doors. So what we have here, if I click into this video here, and this shows the fire has started. So what we have here is, this is the fire door, and this is how fire doors are tested. So at the other side here we have a flame being hit at the door, so a constant flame, so as if a building is on fire. And what we'll look at is on the other side then the fire door, so we're looking for any smoke to escape out through the door. So, and all of these fire doors are tested in this factory condition. So we have what looks like a flamethrower in this video here shooting at the door here. So what it is, the smoke can be stopped. So what we have here then is, this here is after 8 minutes here. So 8 minutes here, there's a bit of smoke coming out through the door here, out around the lock here. So what it is, what hasn't happened here yet is the intrusion strip hasn't sealed shut here. So what we have here is no so what it is, if you, this here is the time, so this here is the time that's counting down. So this has been on for 8 minutes here, and what you notice now, after, once it got to the 9th minute here, all the smoke has stopped. So we're 21 minutes into this test, and what they're doing here is, this is recording the temperature of the door. So the door is 45, 39, 40 degrees Celsius. So that shows how good an insulated door it is. So we're down to up to 21 minutes there, showing the door withstanding the fire. Now there's another video here, and the video down here for you to click in your own time is to show you 3 fire doors, but 2 of them constructed incorrectly, and shows you what happens if you put in fire doors and they're not constructed properly. Now these doors can be looked at, or this video can be looked at in your own time. The next section that we look at is sections of doors. So these are drawings of doors. So how we go about drawing drawing the doors. So if we zoom up on this section here, and we look at the top, or the head of the door first. So this here is the head of the door. So this here is now what's going to be called the old method of building, because there's a new technique for all new houses. So we'll be going away from this 150mm cavity and 100mm insulation, but I'll show you in the next section the new drawing for this door type. So what we have here is we've our vertical DPC placed in here, we've our 2 lintels here, and then we've the door frame, and then we've the top rail of the door here. So we'll have a look at that in detail. We have our lock rail in the middle here, and then what we have down underneath here is the construction here. Now a lot of this construction has now changed. There's no longer any more cavity fill placed in here. The radon barrier is still placed in. We still have insulation on the floor here. This concrete sill here has to be put in, but we'll have a look at how we draw this. And then we have this water drain channel here, that's still placed in. Now we have what's labelled here is 15 degree pitch here on this piece of concrete here, but we'll have a look at that in further detail. Now if we look at these diagrams in slightly larger, what we have here is the top of the door. So you'll notice that the door frame here is fitted against the outer wall up against the DPC, and the shape of the door frame here with cut out at the top of the door frame here, again to stop the top of the door frame from twisting. It's just a release cut here to stop timber from twisting. Now we have lintels placed in here, 2 bricks overhead, and then blocks overhead that. Now if we move down along the diagram, we have our lock rail in the center, and then we have this detailing placed in here. So we'll have a look at the new detailing based on all of this, but what we're looking at here is this piece of concrete is placed in here with a slope on it. Now the slope is maximum of 15 degrees, and then what we have is a drain here to collect any rainwater. So what we have is, this is a door design suitable for all users. So whether you're in a wheelchair or on crutches or able-bodied, you're able to enter this house without any difficulty. Now these are the old diagrams now, so these will no longer be asked in any Leaving Cert exam. All new details will be looked at from the passive perspective. Now if we go on to the section here, so these are all passive drawings that have been drawn out by a student. So if we look at these sections here, what we have here is all the new detailing. So we'll have a look at all this new detailing. So if now these are in your OneNote section. I'm just going to open up my PowerPoint here, and the reason I'm opening up my PowerPoint is just that I can zoom in a small bit and show you more detail. So if we look in on this diagram here, now the only thing the student hasn't done, which I would prefer the student to have done, is to draw in bricks in this section here. So this here is 65 mil, so it's 100 by 65 mil lintel. Then we should have a 65 mil brick here, another 65 mil brick here, and then your blocks the rest of the way up. Now we have our DPC placed in here in blue pen. We have our 50 mil insulation placed in here, so it's important that we put in that 50 mil rigid insulation. So again, I'd prefer cross lines here for the rigid insulation. This here is your loose insulation placed in like that. Now next we have this red line placed in here, so that red line is your airtight seal. Now from previous drawings that we've done, we've put in insulated plasterboard underneath here, which could be placed into this diagram as well, the same as the actual passive window design that we've drawn out. Now what we have here, we've our legend here. So our legend here shows all the measurements. So if we look at a few measurements here in more detail, number 6 here is obviously the door frame. So the door frame here is 150 by 80. So this door frame here is 150 wide and it's 80 in depth. Now there's a rebate taken out of it. Now the rebate taken out of it here is 25 mil by 44 mil, because the door width would be 44. So you have a 44 or 45 mil door width here. So the rebate is 44 by 25. Now all this drawing would have to be drawn scale 1:5. So this would be all drawn scale 1:5. So what we have here is, start off, we draw our lintels, then our bricks, then our blocks, place on the plaster, and then we can plaster the inside of the house as well. Don't forget our red line here for our airtight seal, and then to draw the top of the door frame here, we have our measurement over here, 95 by 45. So we draw in this. Then we have 2 pieces of ply either side, and then we've insulation inside in the center of the door here. Remember, this is an external door for a house, so what we have here is, this is your insulation placed in the center of the door. Now if we look at the frame in more detail, you'll notice that there's a 25 mil piece of insulation placed into the door here. That is a terminally broken frame. So all doors and windows now are going to have this technology of thermally breaking, or thermal break in the door or in the door frame. So this here is how you do it. It's insulation placed in this section here. So if we look at this here, it's 25 mil of insulation placed into the door frame in this section here. Now, to start off looking at the base and threshold of the door, again all this will be drawn scale 1 to 5. So this is called the threshold of the door. So to start off this drawing, the student has broken it down into 3 diagrams. So the 3 diagrams are as follows. This here is the first diagram. So the first diagram here shows your foundation, then shows the width of the wall, and again in this case here, the width of the wall, 100 mil outer leaf, 100 mil inner leaf, and in this case here we're using a 300 mil cavity. Then we have hardcore placed in, we have sand, we have an awful lot of insulation underneath the floor, and then we have our concrete slab. So if we look at the next diagram then, the next diagram then is a small bit more added detail. So what we have in this case here then is all this blue section here now is going to be insulated blocks. So these are all insulated blocks. So there's no longer any cavity fill placed in between the outer leaf and the inner leaf. It is all built with insulated lightweight blocks. The next section here, the hardcore is finished off here. The sand, the radon barrier is placed along here, brought up, over, down, across and out. We have our concrete sill here. Now looking at the concrete threshold piece, the threshold piece here and the concrete sill, it goes by both names. So if we look at this here in greater detail, we're placing in insulation in this section here. So this here is to prevent cold bridging again. So what we have here is, in this case here, 70 mil, 80 mil of insulation. What we have here is our concrete threshold piece. It's covering the width of the cavity this time. The height of it is 215, the same height as a block, brought out to halfway out on our cavity, and the slope begins. So this slope, and this is less than 15 degrees, and then outside here we have our drain for our water. Again, there is no particular sizes for this drain, so basically the easiest dimensions to use would be 100 mil wide, and then the depth of it 200 mil. Then what we're looking at here is the inside of this drain with a cover on the outside. Outside here then we have a footpath of 50 mil. Now the next diagram then that we'll look at is the finished section of the door. So the finished section of the door here, if we zoom out a small bit, so what we're looking at here is again brought down from the top of the door. So this is how we know if we have this drawn correctly. What it is, this section is brought down from the top of the top drawing. So what we have here is, this here is our base of our door. What we have is insulation inside in the center, and then our paneling at either side of the door. The other details that we have marked in here, we have our floor. So our floorboards 25 mil in high, tongued and grooved together. We have our saddle, or door saddle, a level saddle now here for the door. And then we have our piece of skirting board put on the inner wall. So we can draw our piece of skirting on here, so that's where number 18 is here. And then we'll say what we have here is showing in blue here, along with the red line for the radon barrier, we have a blue line here also showing. That blue line represents our DPC. Our DPC has to be placed in here because our concrete threshold piece here is going to get wet from rain outside, and water running off the door landing on top of it. So what we have here is this threshold piece here has to be wrapped around with DPC to stop any moisture entering the house. Now, this is the new passive design for buildings. So this here is the full design for this. So what we have is our insulated blocks, our insulation along the inside here to prevent cold bridging, and then a large amount of insulation placed underneath the floor. So in this case here, if we look here at our legend along the side here, it's quite well done out here with, we'll say, all the labels along the side here, and then all the diagram labeled neatly here. And this is what would be expected to be done for a Leaving Cert exam. Now, the only improvements we might make to this diagram is we might use slightly different markings for the hardcore, and then we might show in the blockwork using lines to show in where the mortar joints are in the blocks. Now finally, what we'll look at next is this is a quick revision sheet that you have in your OneNote, where you're given the diagram with all the numbers here, and all we have to do is fill out this legend here. So it's a quick revision exercise for you. Then we'll say list the functions of external doors here. Function of, we'll say, the storm gully. So this storm gully here, why is it there? And then extra detailing around the threshold details of the door here. Okay, so what we'd be talking about there is the seals around the doors here. So that's gone through really well in your construction book. The seals around the bottom of the door here, how the different seals are, how the different seals function. Now finally, we'll have a look at some exam questions. So what we have here is 3 exam questions. So the first exam question here, it's from a higher level paper. So the main external doorway of a dwelling house is designed to facilitate access for everyone. So you'll notice in this case here we have a person on crutches. So what they're looking for in this question is the door frame is a wooden door frame with 12mm thick vertical sheeting on both sides of the door. So very similar to what we're after looking at. Obviously insulation inside in the center of the door. Then the door frame is 150 by 70. So we looked at a door frame 150 by 80, and it's fixed to an external wall of 350mm concrete block construction with an insulated cavity. So we know this diagram is not, or this exam question is not going to come up again. If it's asked again, they're looking for the new specs, more to do with passive design. But the exact same similar question will come up, but just passive design. So what you're asked to do in this question here is draw to scale 1:10 vertical section through the door. The section should show typical construction details from 500 below the finished floor level, including threshold door, door frame, external wall, and 300 above the concrete lintels of the door frame. So what you're basically looking at here is drawing from the foundation all the way up to 300 above the concrete lintels. Now part B of this question, show on the drawing the detailed design to ensure that rainwater is removed from the threshold. So we're looking at the slope of less than 15 degrees and that storm gully then to take away the rainwater. That's what, and all you have to do in your diagram is mark on your diagram that detail. So with B in brackets and an arrow pointing to that detail. Second question here, again from the Leaving Cert exam higher level paper. A more modern take on this door question. The main entrance of a dwelling house is designed to facilitate easy access for everyone. The door shown is a high performance insulated wooden door with vertical sheeting on both sides. The door frame is 150 by 70mm in cross section and is fixed to the external wall. The wall is 100mm concrete block outer leaf, and then it's got a 200mm timber frame inner leaf and 60mm insulated surface cavity, which is on the inside. So you have to remember this surface cavity is on the inside of that timber frame wall. There is another cavity between the outer leaf and this timber frame of 50mm, but this surface cavity is an insulated surface cavity. So basically what it is, you have your 200mm timber frame wall, and inside that you have a 60mm insulated cavity where you have insulation and also space for surfaces. So the surfaces would be pipework or wires. Now the ground floor is an insulated concrete or solid concrete floor with 20mm tiles. So in this question here, draw to a scale 1 to 10 a vertical section through the door showing typical design details from 500 below finished floor through the floor, threshold, external wall, door and door frame to 300 above the top of the door frame. So on your drawing, show clearly design detail to ensure easy access for all users. So again, looking at that threshold piece again at the very bottom of the door. And all you have to do is on your diagram put in a label B pointing to that detail. Now question 7 here, again taken from a higher level paper, but this here is an optional question then. So what we have in this section here is the main entrance to a house, to a 2-story dwelling house, high performance insulated wooden door with a vertical sheeting both sides. The door frame is terminally broken and is fitted with 400mm external cavity block wall with fully insulated cavity. The external wall support for the first floor joists are shown accompanying on the sketch. The first floor is 25mm floating wooden floor on 20mm plywood deck on 200mm by 40mm wooden joists with plasterboard ceiling beneath. So there's a lot of information given in the first paragraph there. Second here is part A of the question is draw scale 1 to 5 this time. Draw a vertical section through a portion of the external wall, door frame, door, first floor joist and floor, showing typical design details from 400 below the top of the door to 300 above the first floor joist. So basically what's shown in the diagram here, but a lot more detail placed in. Show clearly on your drawing best practice design detailing to ensure air tightness at the junction of the external wall and the first floor joist. So basically what they're looking for in this diagram here is to test your knowledge of air tightness. Now if you have studied air tightness and know it, you know this timber joist now can no longer be built into the wall, because when we're building into the wall then is we're allowing air to get into that wall then and for air to move. So what has to be shown in your diagram here is metal hangers onto the actual joists here. So these joists are no longer built into the walls, they're supported with metal joist hangers. So you'll be drawing on your diagram a triangle piece on the end of your joist here and showing this metal hanger going into the wall. So just a line into your wall here, so to show that the joists do not go into the wall. So they're no longer built into the wall, and that's how the air tightness is done. So it's a very easy few marks to get for this part B. But a lot of students would actually just go old-fashioned way of building these joists into the first into the inner leaf of blocks and let it resting on the inner leaf of blocks. In the new practice for passive and air tightness, these joists can no longer be built into this wall. They have to be supported on metal joist hangers, and basically it's just a triangular piece that you draw onto the joist here and place a black line into the blockwork. Now, as for studying this topic, your best preparation now is to attempt to do 2 of these questions. So basically, and what it is, this here is quite a good question. Either of these 2 questions, but remember you're no longer using the 350mm wall. It's going to be at least another 100mm onto this, or it could be 500mm. If you want to draw the cavity at 300mm cavity, that means your cavity wall now will be a 500mm wall in width. So this is the work for the remainder of this week.